Thank you everyone for attending this session. We are presenting, okay, perfect. This session is about Azure Functions. So the goal of this session is presenting you why Azure Functions are important, what are Azure Functions, where Azure Functions are going in the future, and especially a lot of best practices in order to use efficiently Azure Functions in real-world projects. This slide just to say that if you have follow-up questions after the session that I'm not able to respond directly, you can feel free to write me on my socials, and I will respond for sure. I know an agenda for today, but I have some session goals that I want to, I hope to be able to transmit to you. Especially my goals are to understand, transmit the idea why Azure Functions are important in the Business Central projects, where this Azure Function Platform is going, so the future of Azure Function Platform and what changes. Understand what you can do more than publishing a simple silo code in the cloud, because Azure Function is not like that, only like that. And understand the best practices and some tricks in order to efficiently use Azure Functions in the cloud. Because, as I said always, if something is working, it probably is not always maybe working efficiently. So especially in the cloud, you need to take care of that. An alert for this session, because this session is focused on Azure Functions. So we will not see a lot of IL code, some IL code, but very few IL code. We will see mainly other type of codes, like for example C#, because Azure Functions cannot be written directly in IL code. And we see a lot of Azure stuff. So don't expect to see a lot of IL code here. Why Azure Functions? Why we use Azure Functions in Business Central? Why we are talking about Azure Functions in a Platia where we are Business Central developers? Because Azure Functions, especially in Business Central Online, are a need in today. And normally when I talk about Azure Functions, I think that the main point where we use Azure Functions in Business Central projects are what I listed in this slide. So the first need the partner have is executing .NET code in a SaaS environment. You cannot use the .NET variables, so it's one of the needs where you need to do something else, and Azure Function is the most effective way to do that in the cloud. Reusing existing libraries is another problem that partners have. Probably you come from NIV, a long history, you have custom libraries that you use in NIV, and you would like to use that library, maybe also third-party libraries in your Business Central projects, SaaS project, and Azure Function is the way to do that. Azure Function are extremely important for interacting with other Azure services. Business Central should not be a closed box in a cloud world, should be integrated with, and often is integrated with Azure services, and Azure Function is one of the effective way to integrate Business Central with Azure services. So generally speaking, not only Azure services, but also integration with third-party applications. Azure Function is one of the ways to do that. Azure Function is also important for creating serverless workflows. When I talk about workflows, normally we talk about Power Automate. Power Automate, I always said that it's great, but it's not born to create workflows for integrations, workflows for scalability. There are other technologies like Logic Apps or Azure Functions for doing that. And Azure Functions are extremely important to create workflows and timer-based triggers. And then sometimes Azure Functions are also important to create as a layer between Business Central APIs and another applications. Often, I don't want that an external application directly talk with Business Central by calling directly the APIs for many reasons. And Azure Functions is a great way to do a middle layer between APIs and Business Central and the coupled applications. So when we talk about Azure Functions, a common definition that everyone knows is something like a serverless compute service that permits me to run event trigger and code in the cloud without provisioning or managing the infrastructure. So I simply deploy the code in the cloud. All is managed by some other parties, and I don't believe on what's there under the hood. And what normally partner knows about the Azure Functions is that it's something like I, from Business Central, I can send a request to a black box, and I send an HTTP request to a black box, and the black box responds me with the response I want, executing some code, deploying in that black box. But this is one of the models of the Azure Function. Azure Function has not only the possibility to be called and be calling via HTTP and receiving a response, but Azure Function is more than that. Azure Function is normally a fully serverless way to run your Business Central code in the cloud. You create your code, you deploy that code in the cloud, and the infrastructure, scalability, and so on is all managed by you, by the Azure platform. But Azure Functions are not only a code deployed in the cloud that you can call and you receive a response. Azure Functions are as triggers. Triggers means who starts a function. Triggers can be HTTP calls, but also can be events that occurs on other resources in Azure. You can have third-party triggers that calls Azure Functions, and you can also have timer events, an Azure Function that starts every 5 minutes and executes some codes. Azure Function has a full integration with all the Azure stuffs. One of that important, and we'll see later, is the Azure Monitor stuff. So you can integrate Azure Function with Azure Application Insights in order to receive telemetry and monitor the performances. And you can also automate CI/CD inside Azure Functions in order to have an efficient process. Very quickly, what's composed an Azure Function? When you create an Azure Function, you normally start from an Azure Function app. The Azure Function app is what is deployed on Azure. And an Azure Function app is a collection of one or more Azure Functions. Inside the Function app, you can create different functions. And a Function app exposes these different functions to your endpoints. Azure Function, another important part of the Azure Function is the runtime. The runtime is responsible for running your code. And the part of the Azure core services that includes the logic on how to trigger the code and how to execute your code efficiently. Azure Functions has also another important part, that is the scale controller. The scale controller is responsible for managing for you the scalability of the function. So if you call the function once in a year or 1 million of times in a minute, the scale controller is responsible of scaling the functions and granting you the performance you want according to the plan that you have selected. Azure Functions have settings where you can specify some configuration parameters of your functions, and Azure Functions has triggers. Triggers are extremely important because are who starts your function. Triggers, as said before, are not only HTTP calls, but can be events on every resources, like a message in the queue, like a file saved into the block storage, or a timer executed every minutes, for example. Then there's the function code. The function code is obviously the code that it must be executed, and the function code, as said before, is not a YAML language, is one of the supported language of Azure Functions. Today I will show some C# code, but remember that Azure Function can be created with other types of languages, also with PowerShell, for example, you can create Azure Functions. Azure Functions should be, and I repeat that later, should be lightweight and short-lived. You cannot, if you think on, or if you create an Azure Function that does tons of code, tons of processing inside the same Azure Function, that's something wrong. Azure Functions has bindings. Bindings, I will talk in depth about bindings because are one of the most important parts of the Azure Functions if you want to orchestrate processes, not only a code that gives me a response, but something more complex. And bindings are important for that. And I will not spend now time because I will talk later about bindings. When you create an Azure function, you need to, the first thing that you need to create is selecting a plan. And Azure function normally have 3 types of plans: the consumption, the premium, and the app service plan. Every plan has a different type of characteristics. The consumption plan is what normally I suggest to start, because you pay for the number of execution of your functions, and not exactly the number of execution, but is the number of execution plus the memory you use and the CPU you use. So that's why later in the session we'll see some tricks in order to optimize that. Premium plan sometimes is okay, sometimes is not okay. Sorry, consumption plan sometimes could be okay, sometimes could be not okay. And maybe you, in some projects, you need to scale to, for example, the premium plan. The premium plan gives you more power and also more features, like in one of the main features is the integration with the virtual network, or that sometimes is required or important. And there's also another important feature of the premium plan that I will explain later. The third plan is the dedicated or what is called the app service plan. And the app service plan means that, simply speaking, is something like you acquire a set of resources, CPU, RAM, and so on. And inside that, you execute all the functions you want. You are responsible to scale, and you pay not for execution, but you pay for the resources you acquire. So you can execute every function you want without carry. Obviously, if you acquire not enough resources, you need to scale by yourself. Clicker. Okay. Now, one of the big changes in Azure Functions is the execution modes. Azure Functions has historically only one execution mode, what is called the in-process mode. In-process mode means that you deploy a code, and you create a code. This code is deployed on Azure, and this code is deployed inside the Azure runtime, the Azure Function runtime, and the code you deploy must support the same Azure Function runtime. So, for example, if Azure Function runs on .NET Core 3, your code should support .NET Core 3. If you want to use a TLL or library or something like that, that's not support .NET Core 3, you cannot do that. And it's executed in process, so means directly hosted in the Azure Function runtime. Now, Azure Function supports also another execution mode called the isolated process, or out of process. Normally isolated is the common mode, that decouple your functions code from the function runtime. And this is a great improvement because permits you to create a function app, for example, in, I don't know, .NET 6 is the older 7 is the actual runtime running on Azure. And you can use on that functions every library you want, also if this library does not support .NET 6 or .NET 7, because you decouple your function code from the function runtime. So the isolated model removes all the limitations of the in-process model. You have full control over you create and configure your code, full control on the host, and ability to use features that are not directly supported by the host that runs your functions. Remember that the isolated model is the future. So Azure Function now supports both execution modes. We are here in this moment. So Azure Function supports the isolated and the in-process mode, but the future is going for the isolated. So you should start working on the isolated model and take confidence with the isolated model that has some differences compared to the old. Very quickly showing, I will try to switch between slides, and very quickly showing how to create an Azure Function in both modes. Azure Function can be created in different tools. I will use Visual Studio today, Visual Studio or Visual Studio Code. But as said before, you can use PowerShell or something like that. I honestly prefer Visual Studio, but because it is more powerful. But if you want to use Visual Studio Code, because it's a standard IDE for a business center developers, remember that you need to install the Azure Function extensions. Otherwise, you have no support for that. And you also need to install the extension that gives you the language support. So, for example, I use C#, and so I need to install the C# extension. When all that is set up, simply require that. You can go in the command palette and select the Azure Function Create. And Visual Studio Code gives you a set of questions. The first question is where you want to place the file. That's the most stupid question that I can ask. And I place this file in this folder, for example, previously created. Okay, now it's asking me what language I want to support and the runtime. Here is the model that you need to select. You can select the isolated model or the not isolated, so the in-process model. Now I create a function in the old way, so with the in-process model, so I select this. And then you can select the type of function that you want to create. And here you have a set of triggers or function template. As you can see, the most common is the HTTP trigger. I call you with a request, use response me with a response. But there are a lot of other triggers that start from events in Azure or for timer, a function that I want to execute every X. Now I select the HTTP only because I want not to create the function, deploy the function, but I want to show you the skeleton. So I create this, I leave it a name. Here you can select your namespace, class name, and then the authentications. The authentication you can change also later. We see later talk a bit later about authentication. Now I select function. That means I need to call the function with the key. Opening current window, it's okay. And Visual Studio Code deploys the skeleton of my function. And this is an in-process function. So an in-process function, as you can simply see that I have only one file called as my function name. This file defines a function with a name. I can change it as I want. This is the function app, and this is the name of the function that I want to expose. The skeleton is an HTTP trigger, so it's exposing the authorization. I can change it also later. The standard skeleton supports get and post, but if I don't want to support, for example, get, I can remove, and in this way, my function only supports post. The skeleton simply retrieves a parameter name from the query string or from the body of the response if I support post, and gives me hello name or something like that. But I don't want to spend time on that. I want only to show that, explain that the Azure function in process has only one file. This code that you place here, every complex code you want, you can add third-party libraries and so on, runs in the same process as Azure. So you cannot use, if I selected .NET 6, because the Azure function runtime has .NET 6, I cannot add now a library that is not compatible with .NET 6. The other possibility now, I open another window, is to do the same thing. So again, create a function, always the same, I say temporary folder. Okay, and I always select C#, and now I select the isolated model. So for example, .NET 7 isolated. I always select the HTTP trigger just to show the differences. Sorry. Function, and I open this Now the project is created. And this is an isolated function. And as you can see, the main difference here is that now before the file was one. Now I have two files. A program CS file, that if someone of you is familiar with console application, seems like a console application. And the real function file that contains my HTTP trigger and the code that I want to place inside my HTTP trigger. Some parameters here are changed. Before we have HTTP response, now we have HTTP response data and HTTP request data. So a bit is changed, but the logic is absolutely the same. But what's important to note at the moment is that in this case, we have a program file that gives you the access to the startup of your function. So you are responsible here, as you can see in this piece of code. You are responsible for creating and starting your own instance, host instance. So this means that the function code is decoupled from the host instance. Here you can add your libraries, you can add your services that you want, and the host is hosted on the function runtime, and your code is executed in a separate process. This, later I will show some example, this will open you a lot of power, because you can host this in every platform, supports the Azure Function Runtime, so you can also support executing Azure Function locally on your own network without going on Azure. And later I will show some example of that. So this is the main difference. How we create the function code is exactly like before. So here you can add your custom library, you can create your function code, replace this, and put your function code as you want. Okay. Saying that, if slides goes, okay. We have deployed our first function. Later we show more advanced encode. When we have a function on Azure, now I think you know that in Business Central now we have an Azure Function System module that permits you to avoid using the HTTP client and creating manually a calls to an Azure function. But this module gives you authentication, a method to call the Azure function without bypassing parameters, without a few lines of code, without doing that yourself. And this Azure module supports function or OAuth2 authentication. And it's something different if you want to support Azure function keys or OAuth authentication. How to use that, I quickly show with a sample, because probably you know this. So here I previously created an Azure function that creates QR code. It's nothing difficult. It's an HTTP trigger function that receives an URL, and from this URL generates a QR code. You can create a barcode or something like that. What I've done that is that I've used this. This is a third-party package. So this is a library, this library that I installed from NuGet. And so it's a DLL, your custom DLL, my custom DLL, in this case it's a third-party DLL. I don't have the source code of that. But it's just for showing that I can embed a DLL and I can deploy the function in the cloud, and these DLLs are automatically deployed in the cloud, and I can use everything I want from Business Central or something like that. Now, when this function is deployed in the cloud, the function can be deployed in the cloud directly from Visual Studio, or much better from CI/CD, and later I will show how to do that. But when the function is deployed inside Azure, I have, let me close something because otherwise it's difficult. I close the previously created samples. Don't save this. Okay. I can start using, and from using, this function is just to show is a simple function that when deployed on Azure responds to this URL here. So it's a function that I call it QR generator. I use the function key as authorization, and I'm passing a JSON with the URL, and if I test this function, the code is executed, and the function gives me, in this case, is a QR code. And I want to use that from Business Central. So what I want to do here is I want to place in the customer card, for example, a button for calling my code. So here I simply create a function, code unit, sorry, where with the method where I pass the home page on the customer card and it creates a code. If I go to check this code uses the Azure Functions modules of the system app. So I have a code unit for authentication that returns an interface for the authorization and must be used in this way. The method to use is create code out if you want to use code authentication, so functions key, and later I will show an example with auth key. In this case, I need to post a JSON to the function, so I create a body that is a JSON that I can use JSON object. Here is simple, so I can directly create the string of the JSON, and I sending the post request by passing the authentication of the function and my body. If the call is okay, I'm reading the response, and you have the Azure Function Response code unit as methods to read the response from an Azure function as text, as stream, depends on the Azure function what answers. In my case, it's a stream because it's giving me the bytes of the PDF file. And I'm reading that and downloading the function from stream. So what happens is simply is that if I open my Business Central here, I have a customer card where I have this button. And if I call this button, a barcode is generated and is downloaded to my download folder in this case, but you can do what you want, and it's automatically generated. So my code calls an external function that does the processing and gives me the output for me. Azure Functions can also be used not only with, normally people use Azure Function with function authentication, but if you have more security, more enterprise features, scenarios, you can also use Azure Active Directory authentication. And to do that, you need to remember that, I have a function here. The most effective way to do that is start deploying the function in anonymous authentication, and then activate the authentication from here. From authentication, you can add an authentication provider, and Azure Functions supports different authentication providers, not only Azure Active Directory, but also you can sign in with Apple, with Google, with GitHub, or something like that. If you set Microsoft, what happens is that it creates an app registration, as I think you know if you yet used in the past APIs. It creates an app registration, and in this app registration you have the client ID, you have your tenant ID, you need to create a secret as usual, and you have this ID URL, app ID URI, that is the return URL that you need to pass to the Azure function if you want to use Azure Active Directory. So if I want to call that previous function with Azure IT directory, I need to remember that I need to call, the method to call is not the function key, but create auth2 method by passing the endpoint, URL of my function, the authentication code, that is the authentication code that I have in the app ID, the client ID that I have in the app configuration, and the client secret, and then there are some parameters that I think they have some names not friendly. One is what Microsoft calls auth authority URL, that should be this. The URL you detach the token, and then the redirect URL that must be this, in this format. In this case, you are able to log in with auth2, it detach the token. When you call the function, authentication is in process, is done. You have a token, and then you can call the function and reading the response. So both authentication are actually supported by Microsoft. What to use, totally up to you. But sometimes Azure IT Directory is one of the most secure and enterprise-ready features to do that. Slides, please. Okay. Another important thing to remember is that Azure Functions should be stateless because you have no control on when and where a function is executed. So this is one of the errors that sometimes I see when partners are using Azure Functions. If you want Azure Functions that preserve states during a process, I think that you need to have two solutions. One is using, as I show later, queues between the process of the function, or you need to use another type of framework called Durable Framework that is a framework for creating Azure Functions stateless. So stateful, sorry. What does that mean? That you should not do something like this. So, for example, in this case, imagine that this is what I see some months ago in a partner. What this code is doing, this partner wants to control the number of calls to the function and make some logic. But if you do something like this, so request number, global, and every time someone calls, I increment the request number. But this is not correct because you have the scale controller. So when someone calls the function, if I have only one calls, it's okay. But if I have a lot of parallel calls, the scale controller starts, and I have different parallel functions execution. So these counts will not be correct. So you don't need to do things like this in an Azure function because the scale controller acts. And another important and extremely, I think, less known features of the Azure function and cause of problems and costs is the usage of HTTP client in Azure function. What does that mean? And normally, quite often, an Azure function is used because I want to pass some data from Business Central, and from the Azure function, I want to call someone else. 90% I see in partners is that they have a method, and inside that method, they call the HTTP client. But this is absolutely not the best way to do that, because calling HTTP client in the body of a function will create a new instance of the HTTP client every time. And this can create problems that start from big memory usage, so costs, and or more dangerous problem like what is called socket exhaustion. So you have an Azure function that will stop responding. The recommended way today to use HTTP client in Azure function is using an object called HTTP Client Factory. And I think that with the code is much better to explain. So let me, I previously closed the example. Sorry, I need to find this folder. Come on. So in this example, I will show you 3 possible ways, from the worst to the best, of doing HTTP calls from an Azure function. If Visual Studio starts. Okay. So what normally I see is that this is the same Azure function calling simple Azure function is an HTTP trigger calling an external app. In this case, this is a stupid endpoint that gives me some poke data. So the common error that I see is that if you when someone wants to call an Azure function, when we want to create an Azure function calling an external application, do something like that. So creates an instance of the HTTP client object and then calls the other endpoint. This is inside the method. And calling inside the method creates an instance of the HTTP client every calls without releasing resources. And this is prone to what is called socket exhaustion. So if you have a lot of calls, your sockets will be exhausted, and sometimes the Azure function can stop responding. And you have also a big memory usage. So obviously in scenario where you call a few times, this effect could not happen. But imagine you have an enterprise scenario where you have millions of calls to your Azure functions. This can create a lot of problems. So a possible best way, much or better way to do that is do something like that. So in this case, I'm creating a global instance of my HTTP client object, not inside the code, but I simply use this global instance on my method. So this is my function. Here I'm not creating, as before, the HTTP client object, but I'm only reusing what is called what is created as global. And this is much better because I'm reusing connection. The only problem with that is that it can create problem with DNS changes, because if you change DNS rules or something like that in the external service, this is not reflecting the DNS changes. But it's much better than before. So this is the minimum requirement that I suggest if you want to use HTTP client inside Azure Function and not having problems. The best way, and the recommended Microsoft way to do that in .NET 6 and before, and after, sorry, is do something like that. More complex, I agree, but it's, come on, but it's the best way in terms of performances, costs, and so on. That is using what is called the HTTP client factory object. So in this case, I need to add a reference to the Azure Function extensions, NuGet package. And what does this code? I'm creating here a HTTP client factory object. And this is maintained from the Azure Function runtime between the calls. And each time you call the function, the sender creates a new instance and disposes the new instance when the the call is finished. So when I have this created, and in my function startup, here, I need to add the HTTP client object. And I can also create more than one. For example, if I have one service, and then here I can create also what is called name service. So a new HTTP client with a name. And inside my function class, I create an instance in the constructor of the function class. I create an instance of the HTTP client factory object by passing my HTTP client object that I want to include in that factory object. And then in my functions code, I simply call the HTTP client instance, one of the HTTP client instance that I created inside the factory. So now this, or for example, if I uncomment, you can also create the HTTP client with names. And this is the recommended way to do that. So what you need to do, to repeat, is create an extension of the startup function where you configure the what is called the host builder. You add your instance of the HTTP client, and then you create a constructor like this with the HTTP client factory, where you put inside that the definition of your HTTP client objects, and then you can use that. This is automatically disposed efficiently by you, and you will have a great impact on performances and on cost if you use that class, because memory is not used, efficiently used, and so on. Okay. Then another problem that normally I see on Azure Functions is related to timeouts. Azure Functions have some timeouts that you need to respect and remember. Consumption plan has a default of 5 minutes and maximum of 10 minutes. The premium plan is much more. So sometimes if you have a function running for a lot of time, you need to change plan accordingly. Remember, because this is a common error, that regardless of the function timeout app plan that you have, if you are using HTTP calls, you have a timeout that is maximum this number of seconds. This number of seconds, not 5 minutes or 30 minutes like in the top of the slide, because this is the default timeout of the Azure load balancer that handles the HTTP client. So you cannot go above of that. And another big problem of Azure Function is what is called the cold start. Consumption plan is the recommended way to start, but in the consumption plan, Azure Functions can be placed to sleeping from the Azure Function runtime when not in use. And the next time you call a sleeping Azure function, it takes a bit of time to react, to go your function up before responding. This is sometimes a problem, especially, for example, if you use Azure Function as a webhook client for Business Central, because webhooks, you need to create a subscription to the webhook and a response in a particular timing. And sometimes if you have an Azure Function sleeping, the handshake fails because the other party is not responding in the time that Business Central requires. So you can solve that in 2 ways. One is going to the premium plan, where you don't have a sleeping instance never. You have always an Azure Function app running. Or the second possibility is to ping. If you want to still remain in the consumption plan, you can create a timer trigger function that pings your endpoint, or using things like application inside that has the ping methods to ping an URL is totally free. And this permits you to have always an Azure function running. Remember that because it's a problem sometimes. Another tricks that I suggest to you to remember is if you are using timer trigger function, if you create a timer trigger functions, normally you can specify the timing of your function execution. For example, in this case, is a cron expression that means 5 minutes, every 5 minutes. This is the default as Visual Studio or Visual Studio Code are doing, but this is not a best practice having these are coded, because if I want to change these, I need to go again into the Azure function code, change that, redeploy, and so on. So it's not recommended to do that. Normally, the best way to do is making that dynamic. And to make that dynamic, you can use a syntax like this. Put your variable names inside that. And in this way, you can retrieve the timing from a local variable. If you have a local variable, because your Azure function can be also locally executing, locally debugged, and so on. So a local variable can be placed in the local settings file in this way. And here I'm placing my string. And when I'm in debugging, this will read that. And I'm totally dynamic. When deploying on Azure, you need to go into the configuration tab, and you can add here your variable with your timing. And this will be totally dynamic. So never, please, leave this inside the Azure function, because otherwise you need to change. It's not dynamic. And then now, one of the most important, in my opinion, part of the Azure function framework and is the bindings. The bindings is the possibility to declaratively connect other resources to your Azure function. And let Azure function take care of the rest. So you simply connect Azure resources to your endpoint, and nothing more than that. And these are one of the main building blocks if you want to create workflows in the cloud. Because if I have one single function that I call and responds, I don't need the bindings. But if I have something like this, the example that I will show now, in this example, I have a solution where an external application needs to place an order. So call my endpoint that receives an order. My endpoint needs to check if the order is valid and then giving immediately a response to the customer. Then it needs to save an order into a database. Then needs to create an invoice for that order and place this invoice into a blob storage. Then need to send a mail to the customer. And also I want that daily, weekly, I don't know, a process that takes all this created order and generates a daily report of the order. So it's a big process, complex, that I want to handle with Azure Functions. And here I have mainly two problems. The first problem is that it's absolutely not recommended to create a monolithic code that does step 1, step 2, step 3, step 4, because it could go outside the timeout, and it's not reliable if something fails, transaction is failed. So I would like to have a transaction of this process reliable. And so this means that between the steps, I need to place something where my data is safely stored, like queues, for example. And I don't want to handle the insertion of data into the queue directly, so I don't want to create some separate functions with the queue trigger, timer trigger, or something like that in order to handle that step. I can do that, but I can also use bindings. And to show that, I have sometimes the mouse is not well responding. I have this. Let me close something. I have this project. Okay, this project is a project. First, I start, and then I'll explain. I'm executing my function, and then if I remember where I place the folder, no. Sorry, because I don't remember the folder name where I placed the, okay, this folder. Because I'm searching, okay, I'm searching for this file. That is the file where I have my sample calls, okay. The first thing that you can see when I deploy, I run this Azure function locally, is that here I have one endpoint that is waiting for calls. So this is the endpoint that is waiting for my calls, called receive order. And the other are not endpoints that wait for calls, but are endpoints that react to events attached to other resources. Like, for example, here I have a queue trigger, I have a timer trigger, and I have a blob trigger. Because in my example, someone calls this, passing me an order. When I have an order, I put that order into a temporary queue called received order. When the order is placed like that, this is the function that creates the order will be stored in a database. In my case, it's a table storage on Azure, but can be Business Central, for example. Then there's a function that when the order is safely stored, create an invoice and put the files to the blob storage. Then I have a function that starts from a blob trigger and sends an email to the customer saying that this is your invoice for this order. And then I have a timer trigger that creates the periodic generator. So if I if I execute a call, so this is a stupid order. Let me know if I am able to do that. I'm sending an order. So the order arrives to my Azure function as a JSON. This is the JSON that I'm passing to the order. And then it's placed into the queue. And then when it's on the queue, later I will explain the code, but I'm creating a object that this JSON that I'm passing to my table storage in this case. Here you can call Business Central, for example, if you want to store on Business Central. And then everything, the process goes. So what happens is that if my process now is finished correctly, what happens if I check the log here? You can see that a lot of tasks are done. So here, the report generator function is started. It's the timer trigger that is started. Then the sales report generator, this is the starting of the sales generator. This is where the function that received the order is started. The function that generates the order is started after that. So it's giving me some output, like generating invoice for order X, blah, blah, blah. Then the send mail to customer process is started, and it's giving me some details that I place in the log, like what is the file, the order processed, and so on. And the report generator is started. So all my steps of the workflow are started. Hence, if something fails, the transaction is not broken. I'm not losing orders because I use a temporary storage between the steps of my workflows. To do what happens under the hood in my Azure, I use this storage account. And in this storage account, I have some containers, blob storage. One is called invoice, and one is called reports, where I should have the final invoices. These, if I can download, or let me click here, download, and it's a TXT file, in my case, containing the, come on, okay, containing the invoice for that order. And there's also the reports, where I creating the reports for the order. And where is? Here I have the first queue called order received queue, where when I receive an order, I temporarily place the order in that queue that now should be empty. And okay, it's empty because the order is taken here and processed immediately by the other steps of the function. If something fails, the order is still in the queue, so next iteration, I will retake that order. So I never lose a transaction. And that's important if you have complex workflows in the cloud. And then I placed the orders in a database. In my case, for simplicity, I use a table storage. So if I use the Storage Explorer here, I should update and should be an order placed on that. How to handle that in code? I have used bindings for doing that. So, but what are bindings? Bindings are possibility to, in the trigger definition, declare what resources are attached to that trigger. So in my case, this is the standard HTTP trigger called order receiver. But I added something more to that. I added a queue trigger, so a queue binding, so saying that when you receive an order, you need to place that into this storage, this queue. And I have also another binding with a table storage called orders table. Bindings means that I don't need to do connections, do authentications, or something like that. All is handled by that process. And in these steps of the process, so the receiving part of the order, simply with bindings, I'm reading the order and I'm placing the order in the queue, and then I'm placing the order, the JSON of the order in the table. Stops. Here I don't have connection with the queue, authentication, storage, connection string, and something like that. All is handled by the bindings. Then, let me stop this, otherwise. I have the other steps. So, the first is the order receiver, then I have the generate invoice. The generate invoice is a queue trigger, so starts from when the data is inserted into the order receiver queue and generates the invoice. In my case, it writes a file into the blob storage. And when a file is written into the blob storage, I have the sales report, the send mail to customer function that, as before, now this function has an input binding with the orders table. So parallelly, when the first function saves the data into the table storage, this starts parallelly and sends the email to the customer by reading the data from the table storage and placing the data into my, so this order row object is the row of the table storage that I've inserted, and sends email to the customer. I'm using the output binding for SendGrid. SendGrid is a tool in Azure for sending messages, SMS, or something like that. And then I have the sales report generator, that is a function that periodically, so with the trigger that I want, reads the table, the orders table, and creates a report for my user with today all this order was passed from the external application. So bindings are important in order to create concatenation between steps without writing custom code or something like that. Another important part, a new part of the Azure function isolating in this case, only isolating mode, is middlewares. Middlewares is the possibility to create something like a pipeline between Azure function execution. When you create an Azure function in the isolated mode, this function has, you send the request. Where is the clicker? Here. You send the request here, and normally this is the function that responds and gives you a response. But Azure function also has, in the isolated mode, has something like in the middle that you can handle. You can create in the middle and different instances of what is called a middleware that can interact with the data before the functional execution or after the functional execution. And this is important for many scenarios, for example, authentications, logging, or manipulations of the incoming or outgoing request or something like that. Very quick demo of the middlewares. What are the middlewares? Very easy to use. I close this, and I also close this. Otherwise, I have too much window open. Don't save this. Okay. Okay. So here I have a very stupid middleware. So I'm calling a standard Azure function called send message, standard HTTP trigger function that normally receive a name and give a response, hello name. In this case, I'm uppercasing the name. So someone pass name, and I want to retrieve the name in uppercase. Very stupid, but just to show how middleware works. So when in this function, to handle middlewares, you need to, as said before, only isolated model. So this is a function in isolated model as a program. In the program, if you want to handle middlewares, you need to do something like that. So add this line of code that say that I want to use middlewares. So I want to handle some codes inside the pipeline. And what middlewares? The convert message middleware is my custom class, this, that needs to inherit from a class called iFunctionWorker middleware. And in this, I can handle this method where I can retrieve the before, this will be executed before the execution of the function. So here what I'm doing, I'm retrieving the context, so retrieving what I'm passing to me. I'm passing the JSON. If the JSON contains the name parameters, I'm simply uppercasing it, and I'm returning to the middleware by passing updated this context parameter of the middleware. They are all documented. That says that to the Azure function that someone has modified the body of the request, the incoming request. The Azure function does that. So if it's using middlewares, I'm retrieving if I have updated body. So if I have someone has updated my body before the execution, and then if so, it retrieves the updated body. And then in this case, I'm saying hello to my endpoint. So inside the middleware, you can place authentication, custom authentication, for example, logging or something like that. So if I call this, I don't have, I remember if I have yet previously created, no. I need to send the GRET request that I don't have, but as you can see here, first is the middleware we started, not the function. This is the middleware that is reading if I pass the function. Now I have not passed the name, so it goes on error, but it's reading the information. and now gives me an error because it's not in the format that I want. I not passed the execution, but just to show that the function is not yet started. It started before the middleware, and then the function. So if you do a post call or get call with the name parameter, this works and converts it to uppercase. Okay, now another important part of the Azure function that I want to show you is this. Possibility to automatically deploy the Azure function. So lots of time Azure functions are deployed directly from Visual Studio Code to the cloud. Works, but it's not always the best way to do that. And Azure Function has the possibility to, you can create a pipeline in Azure DevOps or GitHub or something like that. So that's one of the possibilities, one of the recommended possibilities. Or you can also create what is called a continuous deployment to an Azure function. Continuous deployment means that you can, when you have the function up running, you can go into the deployment center menu here, and you can connect your repository where you have your function code, GitHub, Azure DevOps, or many others. When connected, you can select your repository, and you can select the branch that will throw this deployment, master branch or other branch that you have. And when you have that, every time someone updates this branch, the code in the in the Azure cloud is updated. And as you can see here, normally you should not do that in the production. Azure Functions has slots production, and you can create more than one simply by going, sorry, slides. I want to do that. Simply I go here, deployment slots, and create more than one slots. So not only production, but you can also pre-deployment, testing, or something like that. You deploy automatically here. Your customer can test with a different endpoint. And when all is OK, you can simply click this button, and your test becomes production automatically, and so on, with all the settings reverted. And this is a good way to deploy Azure Function in the cloud. Another part that I think is quite important for Azure Function is high availability. It's quite common that when you have Business Center, for example, 2 customers, in this case, what I would like to do is deploy my extension to that customer, the same extension. And if my extension calls an Azure function, because maybe I have an app on app source or something like that, I would like that if the customer is in Western Europe, I have the slides, okay. If the customer is in Western Europe, I would like to call an Azure function in Western Europe. And if the customer is in, oops, with the clicker, if the customer is in US, I want to call an instance of the function in US. That these 2 functions has different URLs. So I cannot do something like testing the country of the language of the environment and doing a big case. If customer is US, then this is the endpoint. If customer is Italy, this endpoint. If customer is Belgium, this other endpoint. But I would like to have in my app one single endpoint. And the forwarding of the calls should be handled automatically. And one of the services that I recommend to use for that is what is called the Azure Traffic Manager. The Traffic Manager is a service that permits you to have a single endpoint that redirects traffic to other endpoint, in this case the Azure Functions, according to the rules you want. Rules can be priority rules, endpoint A, B, C, and I can give a priority and redirects, can be, normally what I prefer two rules. One is the performance rules. So your calls is redirected to the function that gives you the best performance in terms of latency. And the other that quite sometimes I use is the geographic routing. Geographic routing means that the same as before. So for example, if I have US and Europe customer, I want the Europe customer calls the Europe endpoint and the other calls the US endpoint. The performance routing is also useful for scenarios like this. So if I set performance routing and I call my function, in case I don't call my function, but I call directly the traffic manager endpoint, so single endpoint. This is intelligent to know, okay, you are calling me from this client that is a client from a particular location of the world. I set to this a performance, so it checks in this moment from this endpoint what is the best performance. Normally is this, but in this moment this is down, so I stop the function or something like that. It automatically sees that this is down and redirects my function to this second endpoint. So it's also able to react to when the function goes down. And it's important, I think. Also for, so what does that mean is that. So simply I have business center in Western Europe. In my app, I don't have a case switching, but I only call this endpoint that redirects to the function accordingly to the routing. And very quickly, configuring Traffic Manager is absolutely easy because just go on the Azure portal and select the Traffic Manager profile. Here you can create an instance. And when you create an instance, give a name, select the subscription, and so on. And it asks you, okay, what is the rule that you want to route traffic? Performance, weighted, priority, geographic, and so on. Performance, stop. Simply, you select your different Azure Function instance, and then nothing more to do. Here, I'm creating, for example, one based on routing, geographic region. So you select endpoint. When you have the Traffic Manager instance, you have a single URL that you place in your app. But that you need to create the under the hood. The under the hood is you select the endpoint. So I click on Add. I select Azure Endpoint. Here I give a name. Here I select App Service, and then you can select your function, the function that you want. So for this endpoint, or this function, for example, can be called by, in this case, I'm using the geographic. So I need to specify the area that calls this function. Okay, this function can be called from all Europe, or I can also go this country, this country, this country, goes to that, always to that function. The other always goes to that function. And in my app, I only use, in my app, I only use the URL of this endpoint, this, and not the Azure Function URL, because it takes it under the hood automatically. Okay, another important aspect is monitoring. Monitoring for different reasons. Azure Function has built-in integration with Azure Monitor, so you can monitor everywhere. And normally when using with Business Central, if the Azure Function is alone, you can connect the Azure Function to an application inside instance by yourself. But if you are using the Azure Function together with Business Central, because it's part of your Business Central processes, is recommended to use and redirect the data to the same application inside of where you have the telemetry data of Business Central, because in this case, if you want to analyze a business process that includes also external calls, you can do that. Monitoring is also important not only for telemetry, in my opinion, in Azure Function, but also for testing. Because one of the problems that I saw a lot of time in Azure Function is that you create an Azure Function, works perfectly, but if a day your users moves from 10 users to 100 users, or you move this Azure Function from 100 of calls a day to 1 million of calls per hour, immediately something explodes. So what I normally do, if I'm able to switch, for Azure Function is pre-testing. So I want to, when I know that I have an Azure Function that can have a big usage or a variable user, I would like to test how my Azure Function goes if I have 10 calls a minute or 1 million of calls a minute. And you can test that with, for example, a tool called Azure Load Testing. Works quite good, but sometimes it's not easy to test if you want to pass, for example, parameters to the Azure Function, JSON or custom authentication. So a tool that I personally recommend, because I like it, it's an open source tool called GoLoad. I can open a terminal here. Sorry, first I open an Azure Function, like where I connected the telemetry, like for example this Azure Function. It's a sorry, not this Azure, because this is an Azure Function. In this Azure Function, I connected the telemetry, so I have application insights connected to that Azure Function, and I can click on View Application Insights Data to check what happens in the Azure Function. And one of the nice features of the Azure Function to test how it works is, for example, going to the live metrics. And in the live metrics, you can live testing your function. So now my function is doing nothing because I'm not calling it. But with a tool like GoLoad, I can do something like that. GoLoad is a tool that you can download from this URL or from NuGet. And in this URL, you have the source code, and you can modify the source code. GoLoad is a simple tool there. You need to you select the name, and you can do, okay, I want to test 10 requests to this endpoint, my Azure Function, for in 10 requests in 50 seconds. In this case, or 1 million in 3 seconds. And if I execute this, mouse, come on, okay. If I open my command prompt, not this command prompt, but the other, because this, okay. I pass my test, and I execute my test. GoLoad starts sending, and you can see that here, my Azure Function starts reacting, so I can see how memory moves. I can see the full stack trace of the calls. So why it's quite important? Because I can see that I can check if with 100 of calls a minute, my Azure Function in CPU and in memory is okay. Maybe if in 1 million fails, or in 1 million the CPU goes up, and I start spending, because remember that spending cost is also linked to the CPU usage and memory usage. So you can monitor that. And when you have tested, monitor, imagine that this is a live Azure Function. You can also go on as usual. I think that you are expert on that. You can go on logs. What is logs? Here. And you can, as in Business Central, monitor everything like traces, like requests, and something like that, and so on. So you can monitor the traces, see what happens in incoming requests, see the parameter properties. You can also, for Azure Function, you can also monitor more than traces, like incoming requests, failures, and so on. So Azure Function gives us access to other of these metrics. Failures, for example, is important because you can see the stack trace of the code and see why this function has failed. And maybe you have a code to fix or something like that. Last part that I think is quite nice, important, and quite new is the possibility to run Azure Function on Docker. Azure Functions in the isolated model, as said before, are detached to the function runtime. So this means that every platform that supports executing the function runtime, .NET Core or something like that, can execute your Azure function. So imagine that you have a scenario where you have invested a lot of energy and money and so on developing Azure functions for your solutions. And you have a customer, I don't know, like a banking, like NASA, something like that, where security is extremely important. And they absolutely don't want the cloud. If you have this problem, you move the code that you have placed into Azure Function in something like that works on-premise, or there's a problem. With Azure Function in the isolated model, you can solve that by embedding the Azure Function inside Docker, for example. So doing that is quite easy. Just do 3 commands that I listed in the slides. So the first is this command creates a function with this name, with this runtime.NET isolated, and specify that I want the Docker support. You launch it from the command line. Or from, if you use Visual Studio, right-click the Azure Functions, add the Docker support. Here I'm creating a new Azure function called HTTP trigger. And what happens here is that I have a project, like we have done at the beginning of the session, that is an HTTP trigger function with a Docker file. And this is the Docker file automatically generated for you. That you don't touch it, simply this Docker file starts from an image that contains the Azure Function runtime. What you have to do when you create your function code, obviously, inside this file, as said before, you use DLLs or something like that, what you want. Then, when you are ready, you launch this command, docker build, you select the platform, and you can also place a tag to the image in order to build the image and create a Docker image for you. This runs a bit, not too much, but downloads the Microsoft image, builds your function inside the Microsoft image, and then simply, when you have the image, Docker run, the ports that you want, your ID of the function, and you have the function up and running locally, fully. When you have that, you can also push this on, for example, Docker Hub with Docker push command. And when you have the function on Docker Hub, you can also embed the function in something like Azure Container Instance or other type of platform. And just to show this, here I have previously done before, because live, it takes time, and we are quite around out of time. But as you can see here, in my machine, I have here an image responding to this port. And in this image, I'm simply running an Azure function. So if I'm going to this URL, okay, I want to type, just to show first, if now I'm going to this URL, open a browser. First, I remove the function. So just to show that, simply go in this. You can see that what answers me is the Azure function runtime. So it's saying me that, okay, it's not a custom application. This is the Azure application saying me that, okay, you are calling an Azure function, local, running, but it's wrong the URL because I'm not calling the Azure function in this case. But if I call the right URL, that is name of the host slash API slash name of my function, by passing parameters and so on, the Azure function is responding. And this is an Azure function totally running locally. So in scenarios where you have tons of Azure function for your business and you have a customer that don't want that, this is a possible solution. So this ends what I want to show about that, what I recommend for real-world projects. I open to questions. If we have about 4 minutes for questions. So sorry if I don't see after the third line, but it's like in the stadium, there's a light. I saw I launched this. No, I don't know if I don't want to center someone.
Hello.
I don't see you, sorry. If you
Is it possible to debug Azure Functions in
production?
Yes.
Yes, it's possible to debug in production. Absolutely. You need to attach the function to a process. There are a set of steps. So quick answer is absolutely possible. If you want to show the steps, I have some slides to show for the steps, not planned for the session, but I can show that the steps needed. You need to, simply speaking, you need to attach Visual Studio or Visual Studio Code to the Azure function process called vpc.exe, and when attached to that, you need to place the function in debugging mode, temporarily in debugging mode. And then you need to attach to a process from Visual Studio or Visual Studio Code, and then you can debug. I cannot explain now the steps because you shouldn't see that. If you want, I can show how to do that.
And another question, sometimes logs appears not directly after call of Azure function, but in some time, maybe in 2 minutes, 3 minutes.
Logs, yes, but this is a standard of application insights. So logs comes after a delay, are collected immediately. But in application insights, if you go on traces or something like that, you have a delay. Also in Business Central, it's like this. It's not automatically live. So in Azure Function, you can go into the live session, as I showed before, and you see live what happens. But if you go on traces, on requests, and so on, there's a delay between
Is it possible to decrease
signals.
this delay, or it's not possible?
To have in that real time?
Yes.
Real time, no, because it's handled as is by the Azure platform. So there's a delay between when the front end shows you the logs.
Okay, thank you.
I have, if you go here, if you have other questions, I have 3 shirts or 2, I don't remember. 3 shirts to show. Thank you.
In your serverless order manager, this is basically you made it as fire and forget. right? BC sends
Yes.
the request, we get 200, BC gets the 200 back, for BC it's done. And you implemented the retention policies, all the stuff. But what if, for example, if you have data errors, consistency errors? So in your example, you also send the email. If the email is wrong, how do you then make the process safe that BC gets aware that it needs to be restarted or corrected?
If you want to have a reliable workflow with Azure Functions, normally you should have steps between the workflows. So as in the example, for example, with the bindings, I'm not directly doing the steps call and receive, but I'm using middlewares between the steps. So for example, queues or something like that. They are storage that costs nothing and permits you to have a reliable transaction. So for example, if I need to send an order and during the order processing, Business Center needs to take this order and creates a sales order in Business Center, for example. And something fails during that, the order is still in the queue. So next time you re-execute the function, the order is taken to the queue again, and the process fails. If it continues to fail, obviously you have logs, you can inspect why the function fails, and you can fix, but the order is still in the queue, so you don't lose transaction. If you don't do that, so if you have a workflow that simply call a function, give me a response, and someone from the external passes you an order and the function fails, the order is lost. So you don't have notifications. If you want to do that, a complex workflow in the cloud should be reliable. Reliable means that you need to handle queues, multiple steps, or something like that in order to have a reliable workflow. Otherwise, it's not possible. Long-running workflows, Azure Functions normally are born to be quick, short-lived, and so on. If you want to have a complex workflow, you need to do like in the example of bindings and that you have in the slides, that uses steps and uses a middleware between steps. This is the only possible way to be reliable. The other possible way, not explained in this session, is using another framework called Durable Framework, that is an extension of Durable of Azure Functions, quite more complex. But Azure Durable Functions does exactly the same. So out of the box, when you have a step, they automatically store this step into a queue, or automatically without you'll be aware of that. Every step is stored in the queue, and then execute the next step, the next step, the next step. If a step fails, you have the transaction saved, and then you can repeat and so on. So it's the only possible way to have a reliable transaction is using that. Otherwise, calling and receiving, yes, if the transaction fails, you can log, obviously, but you need to handle by yourself. I don't have other gadgets. If someone has other questions, sorry if I don't see over. Oh. Sorry. I'm sure that someone
You
go to the
you
hospital.
have some considerations of directly calling Business Central APIs, and you prefer to put Azure Functions
Yes.
in the middle. Is it only because of the coupling, or because of some other limitations that you faced with the Business Central APIs to call them directly?
No, sometimes I don't prefer call directly Business Central API, honestly. It depends on the scenario. In many scenarios, you know that Business Central API has some operational limits by design. If you have an application that calls frequently Business Central APIs, or maybe cannot use the same authentication of Business Central, you don't want to expose directly Business Central APIs, like personally I do in many scenarios. You can create something like a layer between Business Central and your external application by using Azure Functions. So the external application calls your Azure function in the way you want, with the parameters you want, with the format you want, and so on. And then you, in the back end, inside your Azure Function call, you call Azure Business Center, so you know the Azure Active Directory authentication, how to do that. The other don't care about that. You know how to call the APIs. This is an effective way because you can avoid the operational limit. Because if I have an external application, imagine that I have need to interact with the production machine that sends me like IoT scenarios that can send me tons of millions of signals every minute. I cannot do, and I want to do something in Business Central. I cannot interact that to Business Central because there are limits. So Azure Functions are good for that because you can create an Azure Function. Azure Function can have no operational limit on that. So you can receive all the requests you want, in the rate you want, in the format you want. And then you can call Business Central as you want. So for example, typical scenario, I can place these millions of requests per minute in a queue or something like that. And then I can process that. And I can call the Azure Function with the rate I want, the Business Central APIs with the rate I want. So this is a quite common scenario to have Azure Function decoupling Business Central from the external application. Honestly, I recommend in many scenarios to do that. If the scenario is simple, app A calling Business Central sometimes, and the app is maybe handled by you or something like that, that you know how the JSON should be created, how the call should be created, and so on, okay. But it's often quite common that the external application don't want to create a JSON like a Business Center requires. Is not able to handle Azure Active Directory authentication. Okay. So it's quite common. We have to, I think, if the question is quick, I have the time for another question or not? No. So, if you can wait, or you can jump here.